Hello, and welcome to this video series where I'm going to go over the second recurring worksheet of the semester. You may remember I did the first one before, now we're doing number 2. So I'm just going to get right into working through these problems and show you kind of how I would do them. This first problem is called Read Me, not to be confused with the Neal Stephenson novel Ream Me, but let's just see what's going on. So basically, this is one of those problems where we're basically just giving you a method and we're asking you, what does it do generally? So my general tip on how to approach these problems is to just pick like a random array or something, because this one takes an array, and just work out on paper what's going on. So let's do that and see what's happening. So we have this method, private static Boolean method 1, which takes an int array of values. So it's returning a Boolean and we need an int array to put in. So let's just create one for the purposes of doing this. So I'm going to create length for int array just for fun. I'll pick some random values for it. Let's do 3 and 5 and 1 and 2. It doesn't really matter. Great. Okay, and let's see what's going on. So first thing that happens is we instantiate an int k, which is equal to 0. The next thing we're going to do is we're going to say while k, which is at first 0, of course, is less than values.length minus 1. We're going to do some stuff, and then kind of looking ahead a little bit, I see we're just saying k equals itself plus 1 at the end of this loop. So before I'm even looking at what the loop itself is doing, I already can kind of see k less than values.length minus 1, k equals itself plus 1. All we're going to be doing is iterating through every element of this array in some capacity, right? This is equivalent to writing a for loop that says, int k equals 0, while k is less than values.length minus 1, k plus plus or whatever, right? It's just written as a while loop. I don't know why it's written as a while loop, maybe to make it more confusing. Okay, great. So we know we're iterating through the array. That's kind of the first big step. So let's see what we're actually doing now. So the statement says if values at k is going to be, let me write the indices here. K is going to start at 0. So if this value basically, because we're starting at 0, is greater than the next value over k plus 1, right? Which is just, of course, 1. So if 3 is greater than 5 in this case, we're going to return false. 3 is not greater than 5. So we're going to move on to the next one, right? So now we're going to go to the end of the loop, increment k by 1. So k goes from 0 to 1, and we're just going to run the same thing again. So we're going to say, okay, if values of k, which is now 1, is greater than values of k plus 1, which is 2, we're going to return false. In this case, 5 is greater than 1, so this array would return false. So that's great. We've ran a loop of what's going on, but we probably don't exactly know like what the loop is doing yet, what the method is doing yet. But there are some hints here. So what was that process doing? That process was just comparing elements. It was comparing one element to the next one over, one element to the next one over. And you can assume if we were to continue, we would do one and the next one over, just like that. We're looking at adjacent pairs of elements, and we're comparing them based off value. So you might be able to see what we're probably doing if you think about not what happens when you return a false, but if you think about what situation would you return a true, you might be able to tell what we're doing already. But just for the sake of demonstration, I'm going to give you an array that I think is going to return true, and hopefully it will be clear what we're actually doing with this method. So we're just going to go with it's an ugly 2, with 2 and 4 and 5 and 7. Again, these are some random numbers, and we're just resetting the method. We're going to run it with this array. So first thing we do is we instantiate this k equals 0. I already reset that. And now, again, we know while k is less than values .length minus 1, we don't really even have to look at that because we know we're just iterating through the array. So we're going to look at the first thing, the thing at index 0, and we're going to compare it to the thing at index 1. And we're going to say, is 2 greater than 4 in this case? And it's not, right? So we're going to move on. We're going to say k equals itself plus 1. Right, so then we're going to look at the thing at index 1, compare it to the thing at index 2, right? And we're going to say, is 4 greater than 5? It is not greater than 5, so we're going to keep going. Now we are going to say k equals 2. So first we're going to check, is k less than values.length minus 1? Values.length minus 1, of course, is 3, right? So we can continue this loop. And then same thing, is this number less or greater than this number? It's not, so we're going to continue the loop. Now we're going to increment k to 3, And this first condition is k less than values.length minus 1? Values.length is 4, minus 1 is 3. So the question is 3 greater than 3? And the answer to that is no, right? It is equal to 3. It's not, or sorry, it's not less than 3, it is equal to 3. So we're not going to run this loop again. And that would make sense, right? Because if we did run this loop again, we would try to compare this element to one that doesn't exist and break the function. So we're just going to break this while loop and go return true. So you might be able to tell what this method does now. This method basically just returns true when the array you pass in is sorted in ascending order, when the elements go from least to greatest. And if it's not sorted, it returns false. This is a very simple, not sorting algorithm, but it just checks if something is sorted. And I think it does it in a very kind of intuitive way, right? This is similar to how a human would probably check if this array is sorted. You look at the first thing, is it less than this? Is this less than this? This less than this? It's just written out explicitly in computer code, basically. So that's what the first method does. Now let's look at the second one. The second one is called method 2. It also takes an array of values and it does some stuff. So I'm just going to use the same approach we had before. I'm going to create an array. I'm just going to use the same values we just used, which was what? 2, 4, 5, 7. This is our array. Indices 0, 1, 2, 3, just to keep track. And let's just run through and we'll just see what's going on. Okay, first thing again, int k equals 0. So we have a k, it equals 0, just like before. So this while condition, though, is going to be different. So the while condition now saying while k, which is initially 0, is less than values.length divided by 2. Values.length is 4, divided by 2 is 2. So while k is less than 2. That might seem kind of weird, but again, let's look ahead a little bit in the loop and try to get an idea of what's going on. Again, I see k equals itself plus 1 at the end. So I know that we're kind of iterating through the loop, right? That's probably what we're going to be doing. I also see a values k here. So we're probably just going to be going through the individual elements in the array. And keep in mind that values.length divided by 2 means we're going through half of them. So I don't really know what this means yet, but I know that we are going to be going through half of the elements in the array. So let's now actually execute the code and see what's going on here. Okay, so first thing we do is we check, is k less than this? Is 0 less than 2? It is. So we're going to run the loop. We create a new variable called temp, and temp is going to be set to value of k. K is at first 0, so this is value of k is 2. Like that. Great. Next line is we're going to say value of k, which is this number again, the same thing we just looked at, is now equal to value.length minus 1 minus k. This is kind of a long statement. It's kind of confusing, but you can kind of break it into two parts. Value.length minus 1 just means the last element in an array, pretty much, right? Because the length is 4, but the last element is element 3 because we're 0 indexed. And then minus k. K, of course, at first is 0. So it's going to be the last one, right? And then we're going to say value of index k, which is this 2, is equal to this thing. So this is going to change to be a 7. Right here, you might already be able to tell kind of what we're doing, because you can see that we've chosen the first and last element of an array. We've stored that first element, right, in a variable, so we have access to it later, and then we've replaced that first element with whatever the last element is. So you might be able to see already what we're probably doing, but let's continue a little bit just to make sure. So then we see values of values.length minus 1 minus k, right? That is the same thing we had up there. So this just refers to the last element in the array, is equal to temp. Temp is 2. And so now we've done this. We've just executed these 3 lines of code by rote, but if you conceptually look at what happened, we just swapped the first and the last element of the array, right? And this is a very common way to do this. You'll see this a lot in computer science where you create a temp, you update one value, and then you update the other value with the temp. It's like a 3-stage process to swap anything. It's a really common thing. Okay, so you can probably tell, and also if you combine this information, right, we know that we are iterating through half of the array only, and we just swap the first and last element. You might be able to tell what we're doing here, but I'm just going to do the next one just for fun. Okay, so we get to the end of this loop, and we are going to increment k to be 1, right? So now we say, is k less than values.length divided by 2? Is 1 less than 2? It is. So we execute this loop again. We say temp. Temp is now equal to values of k, which now that k is 1, is 4. Then we say the value at index 1 is equal to the value of length, so going to the end, minus k, which is 1, is going to put us here at index 2. So we're basically going to say this 4 here changes to a 5. And then again, we are going to say that this 5 changes to be what temp is, which is this 4. Okay, and then once we're done with that, we're going to increment k to be 2. We're going to say is 2 less than 2. It is not, it is equal to 2. So we're going to end execution right there. Notice there's no return statement. So we're just going to break the while loop and end because this is a void method. So what have we done? We've just reversed the array, right? We've swapped everything kind of symmetrically, right? We went from here to here and then from here to here. And you can imagine if we had a longer array, what would keep going on? We would keep going in. So that's basically what this method's doing. And I hope it makes sense now why you're only iterating through half of the array, because you're doing, you're fixing 2 indices at once. So you only need to iterate through half to get to all of the indices. Okay, that's how you do that. Some other big picture notes about both these problems. Notice, first of all, that this one is a non-destructive method. It doesn't mutate the actual array at all. Let me get rid of these circles because they're a little bit confusing. Right? Remember that the array we fed in was 2, 4, 5, 6, and then we got it true. We just look at 2, we look at 4, we look at 5, we look at 6. We never change any of these values, and then we just return a Boolean. So this does not mutate the array we passed in. This one, however, does, because after you put the array in, which was originally what, 2, 4, 5, 7, right? It was originally in sorted order. If you try to access that array after running it through this method, it will be this, because we destructively modified the reference type, basically. Okay. That's all for this problem. See you in the next video.